my topic, the magic of versioning, a topic which is, everybody knows about versions, everybody thinks that he knows, or that everybody believes, have some certain beliefs in things. And yeah, why do I want to talk about it? So first of, where do we come from? Me especially in this regard. So we, as a company, and I especially work with OSGi for over 10 years, we are nowadays, involved in a lot of things. So we provide the chair of the steering committee meeting, so me in person in this regard. We are project leads for the OSGi technology project, as Stefan already told you. Are active committers on the specification project, BND, Felix, and a bunch of other OSGi-related projects. And one thing we also do as a company is we provide training and consulting for a lot of our customers around how to build modular distributed systems, and again, especially with OSGi. So, and in the course of doing that, over the years, we found a lot of misconceptions about how versions, which are actually a simple thing, work in OSGi. So, and this brought me to the point of today. And I thought, okay, it would be a good thing maybe to reiterate a few points, even if it's an age-old thing with the versions. So let's start a little bit with the basics. In OSGi, what can you version? You can put versions on bundles, and you can put, where's the version bundle manifest? Right here, yeah, here's the bundle version, and we could also version our exported packages. So nothing too fancy here. In OSGi, we define versions as major, minor, micro, and qualifier, having these elements in this order. The first three elements, major, minor, and micro, are numeric, and the qualifier is alphanumeric. So it can basically be anything you want. So just a bunch of examples for how a version looks. Also nothing new for everybody. So if you just give it a 1, it will automatically be expanded. Non-existing parts will be expanded by 0. And if there is no qualifier is attached. And if there is a qualifier, the qualifier stays there as well for the whole thing. And if you have no version anywhere, it means 0, 0, 0. Important part to remember for later. Versions also can be ordered. So you have to define, okay, which is your version normally. So it starts from the first and goes on to the last part. So 2.0 higher than 1.9.9 logically. 2.1 higher than 2.09 in that regard. 2.1 is higher than the 2.2 release. And here it gets interesting, the 3.00 release bigger than 3.0, beta 2, beta 3 is bigger than beta 2 in this regard. So, and that's something sometimes can be quite tricky. Nowadays it's a little bit less because most people deploy their stuff to Maven and they only use the free versions, but sometimes you find in the manifest still the full qualified version. So which means that when you have something like an RC1 somewhere deployed on Maven Central or something like that, this will automatically be a higher version than your 1.0 release. So we had this thing in the past, so here with a rather old, this Rome library, but I've seen it from time to time as well. So which means when you order your versions or when you do your release versioning, think about the naming scheme you want to use there in order to not screw over other people that might not think about the whole thing. That's a little bit of recommended version naming for the whole thing. Either you leave out really releasing something like alpha and stuff, so put it on maybe Sonatype or any kind of snapshot repositories like most people do, but when you push it to Maven Central or somewhere where the releases are, then go with something like alpha, beta, and then final for the whole thing. Yeah, and try to avoid something like RC1 in that regard. So when the danger might be around that somebody might get it there as well. So this is how versions themselves look for the whole thing. And yeah, in OSGi, we can also version or describe how things are imported, how things are used. So you have two possibilities for that. One is import package, the other thing is still the age-old require bundle thing. So what does this mean? I have my requirement on org API 1, so, and then I get it from bundle B, and I can have a version requirement directly on bundle C. We can get later into what this means in detail and especially. So one important part, when you have an import package, at resolve time, we will come to that later, it will only be matched to any kind of export packages. And will only look at version of these exported packages when you have defined a requirement for a version on your import, where the require bundle only matches against, also its version against the bundle version. So, and there is, and this is something I've thought in the past as well during my times, also way back when, there is no connection between the import package and the bundle version. So, or your exported version and your bundle version. If you don't give a version to your exported package, it has no version. So the version is 000 for the whole thing. When you, for some inexplicable reason, use require bundle, then, and if you don't use require bundle, so basically the bundle version is just marketing in the end. So, and this is how you should see it, because you never should use require bundle in general. But unfortunately, from time to time, you still see it in the wild. I'll get to why this is bad, you will see later on for the whole thing. So OSGi also suggests that you use semantic versioning. Should be a new concept as well, but just to reiterate the whole thing. So maybe start from the bottom. The qualifier part has no real semantics. You can use it for like everything, usually build timestamps and stuff like that. Just give it whatever name you want for the whole thing. The micro part of your version should and can be incremented at every bug fix, every change you make, which has no real visibility or impact on the client itself. Client, in this case, always the user of your API, of your package, of your bundle, whatsoever. So if you make a micro change, everybody can be sure, hey, I can still use it without doing anything about it. The minor part of the version here becomes interesting. The minor part should change if you add features. So something new, like you have an interface in there and you add a method which is new but is not crucial or for the overall working of the whatever the API does there. So and it should not break whatever the client does with it. So if you can use it, then you can just increment the minor version. And a change of the major version in the end means, okay, you basically broke it for everybody. If you use this library in the newer version, you need to do some kind of implementation stuff because it's binary, not compatible, or and sometimes also if you have, however in which order, also if you now need to call a start transaction method before, and if not, everything else throws an exception. So if stuff like that happens, so that whoever uses this knows, okay, I need to do something about it. And I can't simply pull this in. So this is suggested by the OSGi Alliance, now the working group, way back when in 2010 already. And shouldn't also be nothing new. But this is also something where I had the misconception in the past, which is OSGi suggests semantic versioning, but the framework and the resolver does not know about semantic versioning, and it doesn't care about semantic versioning. So you can't expect the resolver by itself, just because you give it a version, or the framework, I want an import with a specific version, that it gives you automatically a version which is compatible by the standards of semantic versioning to the whole thing. So then the question arises, how could this be addressed, or how should this be addressed? Version ranges is the idea how you can use, how to reflect such requirements on semantic versioning, or even if somebody does not use semantic versioning, which is also quite often the case. Just as a few examples, so you may have seen things like that. You not only have one version on your import package, but you have a second version with the different annotations around it, with the different brackets and parentheses. So which means square bracket means this is inclusive, this version. Round parentheses means exclusive, this version. So how does this look like in the wild? We have a couple of examples here. So the first thing, this is version 1.2.3 up to version 1.5.5. So 0.6 is not included anymore in the whole thing. You can also say, okay, I want to include the version 5 if you do a square bracket around it as well. You can also write it like this. So I want to exclude 1.2.3. I know this does not work. And everything in between works, and so on and so forth. So you can put it together in different variations. And now comes also the interesting part. If you just have a version on it, on your requirement, this means 1.2.3 and everything above. So it's basically, yeah, you define your minimal version, but it's also possible that you get a 2 point, 3 point, whatever. So, and if you put no version on it, it's basically give me anything. The first thing you find, just give it to me. By the way, whoever is using PDE, when you start typing and the PDE suggests to you import package, usually it suggests require bundle, and nowadays on top of that, at the first spot you find import package, which is very good. The bad part is it only uses this. So the only thing it puts there is I require the version there. So which is at resolve time will become, okay, the first thing he finds, which is, as the resolver finds, which is above version 1.2.3 you will get. So if you have multiple versions in there, you can see where this can lead. Now I see what Stefan had. So yeah, be aware of that. So because this is one of the, in the past I asked myself, why the hell do I get this version and why does it give me the class I need? So this is usually one of the reasons why this happens. So there's the other thing, sometimes you need specific versions where I say, okay, do you please boil it down? And this is something you sometimes need, but it's rarely used and it's not encouraged to do. So thus it's deliberately made a little bit cumbersome to define such things. So here in this example, you could say inclusive 1.2.3, and my upper limit is also 1.2.3, which really puts it down to this one version. So it would even, as far if I'm not mistaken, ignore any changes in the qualifier, you could only get version 1.2.3. So it might be a better idea to have these half open ranges, how they are called, to be a little bit more inclusive on top. So examples could be something like that, so 1.2, but not 1.3.0, so you would basically get everything in between. So basically, informally, something like 1.2.star. If somebody follows a little bit on semantic versioning, then you can be sure, reasonably sure that you get everything there. Maybe just as a few examples, so in this case you can say, okay, 1.2 is okay, 1.3, this gives you everything version 1, this would give you 1.2.star and 1.3.star, and this one would really tightly pack it and say everything around 3.4 is allowed and is okay. So sometimes it's necessary. Just as an example, when you work with, for example, GraphQL, I'm not sure about the current versions, but at least a year ago, the last versions they released, they only did major versions, so they didn't do any semantic versioning. It's like Firefox, you get, last time they had been at release near to 30 or something like that, and it's basically 0 dot something it would be in reality. So, but they don't do any semantic versioning, so you really need to put in a specific range for what you know works because you have tested all the versions. Thanks to them in that regard. Give me a second. Okay, it's infrared, and if it looks to the other side, it's not working as well. Found the bug. So Given the semantic versioning and how we can put these ranges on, there's one thing to consider when you version your imports especially. So this is what we are currently talking about, the importing part. When you have the API you export, you have two different kinds of interfaces basically, or when you work with interfaces or abstract classes. One is the consumers, and the other one are providers. Because you have certain kind of API which is intended to be implemented by somebody who provides something for this interface. And sometimes you have things that a consumer needs to implement. So namely, a consumer, some kind of an event handler is something which is part of my consumer API. You implement the event handler, and the moment you do some change to the interface of the event handler, you would release a minor change, a minor change, but this would break basically your client who's using the whole thing. And also for any kind of provider, so like the JDBC driver or whatever interface. So this is something I usually consume. If something changes there, if some method gets added, so I as a user don't really care, but whoever implements the driver it needs to be more specific, so he needs to implement something if something changes there. So this can mean breaking changes even if you have minor increments in your whole thing, and you need to be conscious about that. And also you need to address it in your imports. So which means when you have a consumer import, you can have something like that. So I have my example package, and I know it's following semantic versioning, so 1.1 till 2.0 is okay. Whereas when I'm importing a provider thing, I need to narrow the whole thing down and say, okay, 1.1 is okay for me, but 1.2 is not, because something has changed, may have changed, and it might break my implementation on the whole thing. And also sometimes provider, the definition of provider and consumer is, like I said, with the event handler, can be a little bit fluent in that regard. So just be aware of that. In OSGi, we have these annotations which help tooling a little bit along. If you use BND and have your interfaces with annotated with provider and consumer type, it will automatically generate the necessary version range for you when such an import occurs somewhere. So now we have the versions, and now the interesting part comes around. This is how does class loading work in OSGi, because there all these things come together and all these things get handed over to you. And this is where you may see in the wild where you broke your system, or what happens when you do versioning and importing wrong. I just will gloss over the basics of class loading in Java itself. I will not go into details. We basically have, in the default, we have 3 class loaders: the bootstrap class loader, which contains the runtime, the old runtime jar, the extension or platform class loader, which is usually defined by this X folder and everything in there. And additionally to that, the application or system class loader. This is what we usually feed with the class path we define on a normal Java application. And all these together are used to load your classes. And here's an important thing. It always uses class loader delegation. This means if you come around and say, please load this class to the class loader, it will always delegate first to the parent class loader. So which means it will, if you would override Java lang whatever, it will never use this class when you put it on the normal class path, because it will always ask the runtime first. So, and then it will know it hasn't found it there, then it delegates down to the extension, then to the application, and whatever lays above the whole thing. So if nothing is found, you get the magical and always loved class not found exception. Some of you may have seen at some part or another. And also the no class diff found exception. I named this here as well because sometimes you stumble upon it, and I also took some time to really understand what the difference is. So class not found exception means I haven't found the class file you requested in the namespace you have given me. No class diff found exception, which sounds rather close, is when somebody calls new, so that the class is loaded and all the static blocks are filled and initialized, and if something fails there, then you get, and some kind of exception fail comes in such a static block, for example, you will get a no class def found exception, which can be rather hard and cumbersome to debug in the end. Because you think like, okay, it can be deep, deep down somewhere in the whole hierarchy for the whole thing. And in OSGi, you may have seen this in the past. Yeah, it's also one of these can occur when something at runtime is not around or not properly wired to whatever you want. So how does class loading in OSGi work? The class loader hierarchy is basically the same as in Java, but we have a certain distinction. The framework itself is started by a special class loader. And it says all the classes that are on your class path for this specific class loader are available to the framework, and the framework can export them as if they are part of a bundle, so to speak. They can be defined via properties here. And then, when this is the case, also you can, just as a side note, you can also set what kind of parent class loader you want for the whole thing. You can say, hey, framework, your parent class loader is the boot class loader or the application class loader, stuff like that. But usually in reality, this is something you should rarely need to care about. But now we have the framework class loader, which basically takes care of the communication to the outside world of the framework where you're running on. So basically the normal Java application around it. Which mostly is in Eclipse, for example, when you have an Eclipse product, or something else is just a main method which is started somewhere and where all the magic happens. Then every bundle gets its own class loader instance. Thanks, James. I should turn off my Thunderbird during a talk. So every bundle gets its own class loader, and with the parent class loader, the framework defined. So the framework itself is not the parent class loader; it's always then the boot class loader or something like that. We'll get into some detail later. So let's get started. So framework starts. We have something usually called the concept is the launcher, which started. We have one in BND, we have one in Eclipse. Carafe has its own launcher. I guess there are other launchers like embedded in the servlet if you run OSGi inside the JE server or in Spring or whatever. Framework is started, class loader is created, any kind of system packages are exported as they should. Then the bundles are loaded, and the bundles are get their own class loader. And the bundle class loader itself has the classes and resources in the bundle itself. Everything which is defined in the manifest on the bundle class path, so all these include jars in the end, and anything which is a fragment will also be added to this class loader of this bundle. So when something is required which is outside of that space, it's delegated to the foreign class loader where defined via the import or from another bundle. This is puzzled together in a process called resolving and wiring, which means the class loader is created, then the framework looks at, okay, what imports have you defined? Then it goes around looking for who can provide such an import for me. It looks at version ranges and makes sure everybody who has something in this version range and asks for a class always gets the class loaded from the same class loader as everybody else. So especially from the class loader from the bundle this class originates from. So keep that in mind. A little bit of an extra thing, as this is done in the process called wiring. All these things then are cached and the bundle enters the state resolved. One exception is if you ever use it, dynamic import packages, they are resolved on the fly. So if the resolver can't, as if you ask for a class which hadn't been previously defined, and then it says, okay, nobody has it here. We will get to this later in a moment. And then it will try to create such a wiring. So this means when the resolved state is reached, classes can be loaded from it. So I always, in the past, I thought at a certain point, okay, a bundle needs to be active in order to provide something or provide classes to other things. So this is not the case. Always, at the moment a bundle is resolved, you can use, you can get classes from it. So keep in mind when you use static things, static references inside your classes, and something which the bundle activator needs to set a static field you want to use. Keep that in mind. If something from the outside comes around, it's not necessarily the case. That is already. And if you ever use the class loader for some reason, the moment a bundle updates, so by starting, stopping, or something new comes around, it might be possible that you get a new class loader because the bundle reference and all these wirings are recreated. So caching class loaders for whatever reason can be dangerous in that regard. So running a bit out of time. The class loading order, and this is now the interesting part that really opened my eyes. I have all this in writing, but we will jump over that. Bundle exporting, give me a second. Is there something interesting about? Nope. Nope. Stefan's problem. So, like I said, OSGi itself also delegates things. So, and we have this here. Hopefully I have, yeah, give me a second. Can we zoom in here somehow? Is this readable? Yeah, it's kind of readable. So let's go over what happens. Your bundle says at some point, some classes started, you have an import to a foreign package. So, or to a class which is not inside your bundle or may not be inside your bundle. So first thing the framework does, it ignores the class itself. When it tries to load thing, the only thing it looks at is the package. So it says, okay, now somebody wants to load the package. It says, okay, something is java.star. Okay, java.star is always a Java bundle or always a Java package of the core Java API. So it delegates to the parent class loader, looks in there, oh, I found it. Yes, then we are successful. Nope, oh, fails the whole thing. Okay, so it's not a Java bundle. It's not starting with java.star. Maybe it is in the list of boot delegation bundles. So that's a property you can set, please, when you come around and the name pattern matches, like, let's say, java x.annotation or something like that, or java x.inject is in the delegation list. So then it says, yep, it's in that list. It delegates to the parent class loader. If it's found, everything is fine. If not, that's the difference to the normal Java stuff, it goes back and says, so I haven't found it there. What do we do next? Is the whole thing imported somehow? Oh, yep, it is imported. Then it says, okay, I have a wiring for that. Then it delegates to the bundle class loader, where the whole process starts again, but it enters somewhere around here. So if it's found in there, everything is fine. If it's not found in there, then the bundle lied to you where you wanted to implement the whole, import the whole thing from, or you have gotten an import from a wrong version, which is kind of likely when you have no version range defined on your import in that regard, because the framework gave you the first thing it found. So then let's move on. Where are we? So it wasn't an imported bundle, so and then it starts to look into, okay, you have required bundles, or required bundles defined. Then it will go to the required bundles, looks in all their classes in there, so it completely ignores any imports or exports, basically, for the whole thing. I believe in Equinox you can set a strict mode where it also would then look if this is export or stuff like that, but usually if you have a required bundle, you can go arms deep in internal API for the whole thing, and it will look through there, and it will also look through them in the order you have defined them in your manifest, which means first one wins. If you have multiple bundles in there which have the same package, for example, yeah, you get the first one you have in there. So if it's found there, everything is fine. And if it's not found in there, then it will go to your actual bundle class path. So everything before had nothing to do with the classes inside your bundle class path. So if you have a similar package in your bundle, then it would try to load it from there. So if it has not found it there, then it goes through the fragments class paths and looks if it finds in the fragments. If it's not found there, it says, okay, you have exported that package and want the class from it. Screw you, you're out for the whole thing. And if this is not the case, then it says, okay, is there dynamic imports defined? Yes, there is, then he tries to find a wiring for that, caches the whole thing, and tries to load it from there. So this is what happens inside a framework when you load and import a class. So now think about what happens when you have, for example, import, do I have it on my next slide? Yeah. So no, one more thing before we go into that. Equinox, I believe it's Equinox specific, has a mode which called boot delegation, as a compatibility boot delegation or last ditch boot delegation. When it couldn't find anything, it will try to delegate it by default to the boot class loader and say, hey, do you have this package in there? I know when you export an RCP, this is activated by default in the normal, when you start Equinox without anything, this is not activated as far as I know. So why is this important? When you're running, for example, still on Java 1.8, the JavaX annotation package was part of the JRE. The framework itself usually only provides the Java, the forwards to the Java stuff. And if somebody uses JavaX annotation and without declaring an import, it would automatically delegate to the system, to the boot class loader. Some packages, however, had been built with a dependency on JavaX annotation packages and bundles in the version 1.3. And even if you export the system package, you need to give it a version, because if not, some bundles would get the annotation instance from the boot class loader, some would get it from the JavaX annotation bundle, and then suddenly, because you, I believe the E4 annotation parser at some point says, okay, I have JavaX inject, or not sure what kind of annotation it says, okay, I have inject here, but it does not equals inject. So, because they had been loaded with two different class loaders. So this whole thing can really get messy in that regard. So I'm reaching the end. In reality, and when you are in your system and you encounter such things and wonder why classes can't be found, if you have a Go shell, it gives you a couple of tools which can provide you with the necessary insights. So there is the command inspect capability. You can also write it in short with cap. OSGi wiring package. This is what an import package will become a requirement in this requirements and capability model with the namespace OSGi wiring package. Require bundle would become OSGi wiring bundle. You can give it what bundle you want to look at with the ID, and then it will tell you what bundles this bundle, what packages this bundle exports, in which version, and to which bundle it is wired. And if you come from the other side, you can also check the requirements and say, okay, for example, here, what kind of bundles does the promise bundle require? So it says, okay, it has a wiring to, and here you see again, OSGi always uses these filter and expressions, you know, from this LDAP style. It says, okay, I have an OSGi wiring package to util function with a specific version range, namely bigger 1.1, smaller 2, and this is resolved from the package OSGi util function in the version 1.1, the package util function version 1.1 is given to it by the bundle, oh God, OSGi util function. So, and this is how you can see where things come from, and if you don't get what you expect, this is the way to get forward to find out what's messing with you for the whole thing. So, conclusion, I don't have one. No, I have a conclusion, but my wife bothered me that evening, and then I thought I did this part, I do freestyle. So version are a really powerful tool, but not everybody uses them correctly. You can't really expect that everybody uses semantic versioning. But if you know that they do, use the version ranges, use them consciously. Also really think about how you version your exports. Always version your export packages, even though it seems cumbersome at some points, but never leave it out. And yeah, OSGi basically gives you all the tools to resolve any issues that come out of it. But a lot of the things that I've seen in the past that seemed hard and unreasonable are usually due to missing the good metadata in terms of imports and exports to help the system along to do its thing. One of the main examples, just as a closing note here, if you do remember in the PDE, when you have the launch configuration, there's this button resolve. And I've never seen it that I hit it and something came out that worked in the end. And I always ask myself, well, why the hell? So, and then I started using BND and the resolver there, it just worked. And it was okay, that's nice and good. And nowadays, and at the time I thought the resolver implementation there seems to be a shitty one. But I haven't looked what kind of resolver implementation they have, but I'm pretty sure it's not because the resolver is shitty, but because all the metadata it's given is basically shitty. So when you have a mixture of require bundles, import packages, and no versions somewhere, and versions here, and version ranges there, and nothing else, that can't become something useful. And especially in the past, most of you might know the issue of fighting with no class defounds or class not found exceptions. This is usually the case because the people don't provide the necessary things. It's not the fault of the framework. The problem sits in front of the keyboard usually on both ends. So thank you very much. I can also only repeat what Stefan said. If you are interested, join us in some way, shape, or form. Ask us for advice. We are open for everything. So thank you very much. Any questions? Yep.
Thank you for the talk. About the class loaders, could you please talk a bit about class loaders from the security perspective, like the namespace?
I have to admit, the security perspective, I've never really looked deeply into it. I know we support the security manager, but this is something a little bit of a contentious topic because the security manager is about to go away. The only thing I know, from the security perspective, if you use, you can fine-grained control what you export somewhere. But like I said, if you don't run your system in the secure mode and somebody says, I use require bundle, then you can get arms deep in whatever kind of classes and resources you have in there. I don't really know what else I can say about it because we need to ask Tom or somebody else like that when in one of the meetings. Sorry. Anything else? Yeah.
So what exactly is the problem of using require bundle? Because in the Eclipse world, many people do use it, right?
Oh, this kind of worms. Yeah. let me get back to this point here. Require bundle gives you access to the whole space of that bundle. And it really, really nails you down to exactly that bundle. Sometimes you find, for example, these all-in-one jars of something, so on Maven Central, which are quite nice and handy. You may use this at development time because it's easier to put this in your build dependencies. But at runtime, you don't know if this is there or all the different jars which comprise this all-in-one bundle, for example. The result should be the same, but you suddenly have different bundles and this bundle is not around. So that's the first thing. You really couple yourself to that one implementation. In OSGi it as well is quite common to repackage packages, basically. Just take the classes, copy it somewhere else, and export them with the same version, which is no problem because when somebody uses an import and the framework created a wiring for it, everybody who requests something from that package will always get the same class from the same package, from the same class loader. If somebody uses require bundle, it might come from another class loader suddenly, and then you just two classes of the same kind, and the system has no idea that these should be the same classes or packages it should have given you in that regard. And last but not least, now I've lost my train.
Refactoring.
Yes, if you refactor something, it might be possible, if we go back to it here somewhere, one of the first pictures. Here we are. This package I can put somewhere else in another bundle. So if something changes in here, there's no connection, basically. So if somebody moves a package out in the newer version, then you don't know about the whole thing. And the other thing is also, it is sometimes the case that you have a package in your bundle which you export, and when package A in your bundle uses something from package B in your bundle, if you import and export the whole thing correctly, it's not necessarily the case that you get the package from your bundle, but maybe from somebody else who exports exactly the same bundle. So and things like that are also not really possible when you use require bundle. So a lot of things, and they screw over basically all this, or the resolver and the framework is quite capable of resolving all these things and wiring all these things together. And the moment you throw require bundle in there, it blows everything to shit in the end. So, yeah.
It's also the problem that you tie your dependency to a specific bundle ID. And for example, the migration from the Eclipse Orbit provided bundles from third-party dependencies to the ones provided by Maven Central was also quite a nightmare, because in Orbit the bundle IDs were slightly different compared to the ones on Maven Central. This would have been much more simpler if everybody would just have used import package, because the package names didn't change, because the class names didn't change. So
Yeah, and I've usually found that require bundle is, I used it out of laziness in the past, because as a developer I'm lazy. I want to say, okay, this is my build path, like in Maven you define my dependencies, so just import it. I don't want to import every package by hand and myself. Then I just use it, and the tooling should figure out and do all this, calculate the imports, calculate the versions, and only supplement it where you need it. So, but usually, I used it because of my own laziness in the end, I have to admit.
There's also a reason, there's one single reason inside the Eclipse platform itself that makes it necessary, which is the split bundle problem of Eclipse commands and Eclipse runtime.
Yes, yes, we have it in the core basically there. So
Like this cannot be solved without requiring.
that's true. Yeah, and in some cases there is no other possibility, which is true, but usually.
it could be solved with attributes on the exports, but that will be problematic if you one day
We should not discuss this here because this will never end. So, but I'm all for solving this issue. So,
That's one of the reasons why it still exists
Yeah.
and was not abandoned.
yeah.
What about performance issues comparing import packages against require bundles?
I can give you an insight from a few years ago, because there was also a discussion on this, and someone said he migrated partially from require bundle to import package, and the performance got down drastically.
Yeah.
And they found out that the mixture is the problem. If you have require bundle mixed with import package, and then the resolver is calculating heavily. If you switch completely to import package, there is no performance indication.
Yeah. And the only
So
thing.
the mixture is really making a problem in the resolver.
So at runtime, it isn't really that much of a problem anyway, because it's on startup. So they are the wirings, and then they are cached. So and then.
But the startup problem is fine.
Because we figured out that the most promising way to get the application to work stable enough is to abandon import package and use require bundle.
The reason for that is most likely that, when you do this, you really need to handcraft what bundles you put in there, what kind of starting order you give the whole thing, and the whole shenanigans. When you use, as we found, when you start using the full range of the OSGi abilities, use declarative services, don't use bundle activators, use import packages, things run much smoother and are much more stable. If you use bundle activators and use patterns like static, like the usual Eclipse plugin basically suggests to you when you use the tutorials and templates by, okay, I get a service in the bundle activator and put it on a static method or something like that to access the whole thing, yeah, then everything goes to shit. That's true, because the system is quite capable of self-populating itself, but only if you give it the tools. If the system does not know about such things, because about a bundle activator, which sets a service reference, which another service might use, the system does not know about that, these kinds of things. And if you use things like that, yeah, everything gets unstable. That's true. But if you adhere to all the basic principles, I've never seen that things are unstable, and usually they are more, it's easier to exchange parts than when you have this handily curated and it works, but don't change anything situation. Yeah, so that's what I can.
Regarding the performance issue you mix up, is that per bundle or is one require bundle in your whole thing already messing up the performance?
This might already mess it up because the resolver starts right. Also the resolver itself just says, okay, I have a requirement here. I try to resolve this requirement. Then it tries to look if these things are compatible with the other things. When it finds no, it's not, then it basically starts again, and then it runs loops and loops and loops and loops until it finds something which might work.
Yeah, I have to extend my answer from before. The typical pattern in Eclipse platform development was before to re-export packages.
That makes real help.
And that makes a real help, because then not one bundle exports the package because of the multiple levels with the re-exports. Now you have 10 bundles that export the same package, and the wiring is then looking down the stack. And this is really causing pain on startup performance.
And what OSGi tries to do is find a stable class path for each class loader and package. So if you do that, if you re-export bundles, for instance, then you have always two candidates that match a certain package. So this every process has to be done 2 times, and then the resolver has to evaluate one stable path to this package. If you then also mix it up with an export package declaration or import package requirement, then the resolver has to do the things twice. Because at first it prefers import package as a requirement, and the second is the required bundle.
But isn't required bundle the most stable path to find?
If you want to do everything manually, yes, then it is the most stable path. But it works until it doesn't.
And you never have, with required bundle, you will never see your real transient dependencies. You will never see your real requirements in the sense of packages. Because what you always get is a lot of exports, unused exports maybe, that required bundle also exports. And you can never substitute such bundles against very small implementations, because maybe you have a bundle that exports an API and an implementation just in one bundle with
Yeah.
just an
Yeah.
object in this API. You never can extract this in 2 bundles and say, oh, I have now a bundle that exports just the API. And the second one, the implementation, you can never substitute the
I think
implementation.
that is a good example why require bundle can be very difficult. If you have 2 require bundles in your bundle, and then you get all the insights of the first bundle and all the insights of the second bundle. Now imagine this is stable. Now you have this first bundle adding a new package, a dependency that it embeds, but it's there. A different version than the other. You did not expect that, so you all of a sudden, as you have this first, you get a different version of a dependency than before, and you don't expect that.
Sorry to interrupt because we are running too long. Michael had we had one hand up the whole time. Just this last one question, and then we can take it into the break. So.
Should be a quick one. Are you aware of any tooling that would softly enforce semantic versioning to the developers of bundles
Yes.
outside PDE and BNE?
Also, no. Also the only thing that I know that really works is BND. I've never gotten the API-based lining of PDE to work or to mess up my project, and I don't know.
I think the whole BND stack is also for Maven now.
Yeah. Also you can use it in Maven. So yeah. So, but the BND is you doing the thing underneath for you. So.
You would recommend BND as better than this?
For everything, yes. The answer is always BND. Yeah. So, thank you very much. We have a quick break. We reconvene in 20 minutes for Dirk's talk. Yeah.